Hi everyone and welcome back to PrepFusion. I am Anish and today we will start with the lecture 20 of our Transformers chapter. Okay, so today we will discuss about assignment 7 solutions. So this is the first question that is on based on the principle of self and mutual inductance. The self inductance of a primary winding of a single phase 50 Hz transformer is 800 mega Henry. Sorry, not mega, sorry, 800 millihenry. So self inductance L1 is 800 millihenry and that of the secondary is 600 millihenry. So L2 is 600 millihenry. Okay, L2 is 600 millihenry. Okay, the mutual inductance between these two windings is 480 millihenry. So M is 480 millihenry. The secondary winding of this transformer is short circuited. So the secondary winding is short circuited, okay, and the primary winding is connected to a 50 Hz supply, okay, single phase voltage source. The current flowing in both the windings is less than their respective rated currents. The resistance of both the windings can be neglected. In this condition, what is the effective inductance seen by the source? So the source is connected in the primary, right? So here this leakage reactance will be there, LL1. Then there will be the mutual inductance, that is LM1, and the referred version of the leakage reactance of L2. So it will be L2 dash, and of course the other end is totally short circuited. So the short circuit, if I refer it to the primary, it is short circuit only, because 0 ohms, if I refer it, if I multiply any constant number, it will be 0 only. So that's why it will remain as short circuit. So I have to see the equivalent inductance, right? What have they asked? The effective inductance seen by the source. What is the effective inductance? So it is like effective inductance will be what? These two are in parallel, correct? So it is basically here the value is LM1 into L dash L2 divided by LM1 plus L dash L2 plus L L1. Okay, so this is the effective inductance. Sorry, from here. So an additional, this one is in series. So overall my effective inductance will be this LL1 plus this. Okay, so I'll write this in different color, LL1 plus this. So let us find out the individual values. So if I remember, what was my LL1 leakage reactance, I have to subtract the mutual inductance from it. How much? The turns ratio. In which direction I am in? Primary. So it will be the turns ratio of the primary upon the turns ratio of the secondary. So it will be L1 minus N1 minus N2 into the mutual inductance. So what is L1? L1 is 800. N1 and N2 they have given a. Okay, so there is a mistake in the question actually, because they forgot to tell the value of N1 by N2, right? Ratio. So turns ratio is 1. So N1 by N2 is 1. It's a miss in the question actually, or I don't know. In like it is insufficient data. Without the turns ratio, you will not be able to solve it. Okay, so turns ratio is 1 actually for this question. I just saw the solutions. So it is 1. So here it will be L1 is 400. L1 is 800 millihenry. 800 minus 1 into M. M is 480. Okay, so it will be 320 millihenry. Okay, now what about the L L dash of L2? Now L dash of L2 will be, of course I have to refer the L2 in the primary. So it will be N1 by N2 whole square into L2. It does not matter actually, because it is the same value only, minus the mutual inductance, that is N1 divided by N2 into M. Mutual inductance in the primary is N1 divided by N2 into N. So anyways N1 by N2 is 1, does not matter. So L2 is 600 millihenry minus M is 320 millihenry. So it will be 80. So it will be 280 millihenry. Okay, that is what my L dash L2 is. Am I correct? 480, sorry, this is not 600, what am I talking? I have to subtract 480, right? So 480 will be here, it will be 120. Okay, so this is my LL2 dash. And what about LM1? LM1 is just simply N1 divided by N2 into M, so that is 480 only. Okay, so now I will solve this question. So LL1 will be here 320 plus LM1 is 480 into LL2 dash, that is 120, divided by LM1, that is 480, plus LL2 dash, that is 120. So this value comes out to be 600. 1 by 5, 1 by 5, this is 96. 96 plus 320, 416 millihenry. Actually they should have mentioned 416 is here, but I don't know why I'm not able to see that it is a 1:1 transformer. I'm not able to see it somewhere. Okay, it should have been mentioned actually, or I'm not able to see any one of the things, any one of the two things. Let's now solve the next question. Okay, a single phase 2 kVA, this transformer is reconnected as an auto transformer such that its kVA rating is maximum. The new kVA rating will be what? So I want the kVA rating to be maximum. How can I make the kVA rating to be maximum? You remember this. You don't have to remember all the formula. Just remember this, right? That my S auto will be equals to S 2 winding transformer into, sorry, divided by 1 minus NLV by NHV. So this I hope this you can easily remember. This factor you can easily remember. I don't feel it is very difficult to remember. Okay, now I have to maximize it. If I want to maximize it, that means I have to minimize this, right? How can I minimize it? So basically, right, I have to maximize this whole thing. I have to maximize the kV rating. So I have to minimize this. If I want to minimize this, I have to maximize this. So my NLV upon NHV should be maximized. Okay, that means the kV rating should be more closer towards 1. That is what we mean, right? So how will I maximize it? So there are many ways in which you can maximize it. Okay, now it's not like you will always use the formula. It's better if you don't use the formula and directly solve. Okay, it would be good. Of course the formula also will work here, but let's go by basics. Okay, so I will copy from the previous lecture. I will copy this diagram. Okay, this diagram I will copy. Anyone will work. So there are 4 possibilities, right? There are 4 possibilities overall. So we will try to check all 4 possibilities, because gate exam can be a very tricky exam. You don't want to miss something, okay, just by using the formula. Formula will also work, I will tell you, but sometimes if other students don't prefer it with formula, I will solve from basics and then I will solve using formula. Okay, so my 2 winding transformer kVA is 2 kVA, rating is 2 kVA. Okay, the current is voltage here, its primary is 100 volts and this is 200 volts. Okay, and then this, what is the current here? The current here is 20 amperes and current here is how much? It is 10 amperes. Okay, now if I reconnect and let's say I want to, first of all I want to connect the C and B. Okay, if I want to reconnect and connect the C and B, what will happen? So let me delete all this. If I want to connect the C and B, so C will be here and C will be here and B will be here. This will be A, this will be D. Okay, it doesn't matter which side you are seeing from, NHB, NLB, does not matter. Okay, so this voltage will be how much? This voltage will be AB plus BC, right? So this voltage will be 300 volts. This current will be how much from A to B? This current will be 20 amperes. This current will be how much from D to C? It will be 10 amperes. So this current will be 30 amperes and this current will be 20 amperes only. And this is what voltage? This voltage is CD, so this is 200 voltage. Okay, so here what is the kV rating? kV rating, if I see, it will be either 200 into 20, sorry 30, or 300 into 20. So this will be equals to 6 kVA. Okay, this will be 6 kVA. Now let us try other arrangements as well. Let us try other arrangements as well. So if I try other arrangements, now I will not short C and B, I will short D and B. So C will be here and B will be here. So the direction of the current will change and this polarity also will change, although does not matter much, but still this polarity also will change. So this will be minus plus. What will be this direction of a current? This direction of a current will be 10 ampere. Okay, so this direction, this will be 10 ampere only. This 10 ampere is flowing from here, so here again 10 ampere will come here. So overall here 20 ampere will go. Okay, so what is the kV rating here as well? If you see the kV rating here is either 300 into 20 or it is equals to 200 into 10. Okay, something is wrong here now. This direction should be same only, 20 amperes. This is 10 amperes. Okay, yeah, this should be 10 amperes. So this is 10 amperes here. Okay. Oh, what about the voltage? Sorry, I forgot to add the voltage, right? So this voltage will be what? This voltage is 100 volts. This voltage is minus plus 200. So actually here I have the voltage as minus plus 100 volts. Okay, so this will be 100 into 20 or 20 into 10, that is 2 kVA. Okay, in additive polarity only the kVA will be higher, most cases, not in subtracting. But if you ever don't want to take a risk, you can obviously solve with basics. Okay, so let's now choose the other one. Okay, if I connect A and C now, if I connect A and C, so what will happen is this will come here. Okay, and this will come here. So this direction again will flip and this direction also again will flip. Okay, and this dot will come here, this dot will come here. So this will be plus minus 100, this will be plus minus 200. So overall this will be plus minus 100 on this side. Okay, and this will be plus minus 200 on this side. Okay, 200 on this side. So here what I see, like what is the current through this 100 volt will be 20 amperes only. So current direction will be like this only, not like this. Okay, current direction will be something like this. Okay, and okay, E to B to flow. Okay, and here, so here actually this direction will be the current 10 amperes, this will be the direction of the current here. So here the 20 amperes current will come. So it will not change, basically kV rating will not change, kV rating will be same only, 20 into 10, sorry 200 into 10 or 100 into 20, anything works, 2 kVA. In subtractive polarity, anyways the kV rating will reduce only because the voltages are getting subtracted instead of getting added, right? Because current rating is same, 20 amperes 20 amperes, 10 amperes 10 amperes, but voltage getting subtracted. So that's why the kVA will only reduce, right, in this case. So in this case again, if I want to short these two, right, if I want to short A and D. Okay, if I want to short A and D, so I'll copy this thing. If I want to short A and D, so this A will come here, this B will go here, and this D will come here, this C will go here. Okay, so the current direction will change here as well, the current direction will change. Okay, so this will be the current direction here, this will be the current direction, and this will be the current direction here and here. Okay, so now what we can say, kV rating, right? What will be the kV rating? KV rating will be 200 into 30 equals to 300 into 20. So the kV rating is 6 kVA. Again it's the same, only. So ultimately you could have used the formula as well. Directly I could have used the formula. So NLV upon NHV. So I have to maximize this value, right? So how do I maximize? So I will choose my NLV to be 200 and I will choose my NHV to be 300. So like there are many options, right? Either I can add 100 and 200, make it the high voltage winding and the 100 volt as the low voltage winding, or I can make the 200 volt as the low voltage winding, because high voltage winding will be fixed, the additive polarity. Low voltage winding I can choose. So I will choose it the maximum because I want to maximize this value. So it is 2 by 3. So it will be equals to S2 transformer is 2 kVA divided by 1 minus 2 by 3. So this will come out to be 1 by 3 into 2. So that is 6 kVA. So this value will come out to be 6 kVA. So this will be the answer basically. Like you could have solved with a formula as well, but I wanted you to realize, understand what is happening behind the circuit. Why the additive polarity has the highest kVA rating? Because the voltage ratings are getting added. So I will write down here. Additive polarity will always yield in highest kVA because current is fixed, voltage increases. Pardon for my drawing, like my health is not good. Okay, so voltage increases. So I mean handwriting is bad because health is not that great. Okay, so yeah, that was it basically for this question. We have concluded this question, right? We just have not solved the P by Q. I would have just used this formula and we would have ended this question, right? I went into this question, explained every single bit so that everything is clear. So next time same question will not come, but some similar concepts might be asked. So we covered every single thing. Okay, so let's now solve this next question. So here a single phase 22 kVA, this transformer, distribution transformer, is to connected as an auto transformer to get an output voltage of this value. Its maximum kVA rating as an auto transformer. So output voltage I need 24020. So again, like I will not repeat again. So now I need the maximum kVA rating. So so my HV is fixed, that is 2420. I need maximum kVA rating. So I need to fix my VLV to be the highest value. So VLV I will fix as 2200. Okay, why? Explained in the previous question. Okay, so now I will use the direct formula because I have already explained in the previous question. So S auto will be S2 winding transformer divided by the 1 minus N LV divided by N HV. Okay, so this will be S2 transformer will be 2 transformer has kVA rating of 22 kVA divided by 1 minus NLV. NLV is 220. Sorry, NLV is in our case 2200 divided by 2420. Okay, so it is basically 22 divided by 1 minus 10 divided by 11. So it is basically 1 by 11. So 11 into 22. 11 into 22 will give me 2420. Okay, so 2420 will be, I guess, am I correct here? 1 by 11. What are they asking? Its maximum kVA rating will be just hold on a second. The distribution transformer is to be connected as an auto transformer to get an output voltage of 2420 volts. Okay, its maximum kVA rating as an auto transformer can be, its output voltage is this value. What can be its input voltage? Its input voltage will be this. Okay, 1 by is 10 by 11, so this will come out to be, yeah, 1 by 11 into 22. So sorry, this will be 242. Okay, 242, not 240, 242. So 242 will be the correct answer here. Option C will be the correct answer for this question. Okay, so now let's solve this next question. So here I can delete this page. Here we have this statement linked question. The figure shows coil 1 and coil 2, okay, with dot markings having turns 4000 and 6000. So N1 is 4000 turns, okay, and N2 is 6000 turns, okay. So both the coils have a rated current of 25 amperes, okay. Both the coils have a rated current, maximum current that can flow, I rated, will be 25 amperes. Coil 1 is excited with single phase 400 volt 50 hertz. So coil 1 is excited with single phase 400 volt 50 hertz, okay. So it is excited with single phase 400 volt 50 hertz, and both the, okay, the coils are connected to obtain a single phase 400,000 volt. The auto transformer to drive a load of 10 kVA, okay. Okay, I need this value, okay. Which of the following options should be exercised to realize the required auto transformer? So I need to connect them in additive polarity. Why? Because my input side is 400 volts, output side is 1000 volts, but this coil 2, as the number of turns, if you see by the number of turns, if I apply the same in a single winding 2 winding transformer, you see if I have 400 volts here, I will get 600 volts here, correct. So I have to add these two voltages, then only it will act as an auto transformer, like whose output will be 1000 volts and kV rating is 10. So if I connect the C and B, right, because the dot should be connected to the non-dot of the other coil. So if I have to connect the C and D, this we already know, right, because we have already studied the theory. So C and D we have to connect. So if I connect C and, not C and D, sorry, C and B we have to connect. So if I connect C and B, I know the voltage input will be constant. So this voltage will be still the input, that is AB. Like I will take the output from, C and B. I will take the output, no, I will take the output from C and D, okay. Am I correct here? So like how will the transformer be, or how will the transformer be connected? So A and B is here, okay. What I am doing is I am just connecting the C with B. Am I correct? No, I should not, hold on, yeah, that is correct only. I should connect the C with B. So if I connect the C with B, this will be somewhat like this, correct. So yeah, this is CD, this is AB, this is the dot, this is the dot, okay. So uh, I will take the, I will give the input here, but if I give the input here, that will be gone. Yeah, that will not work actually. This will not work. So I have to connect, I have to connect, then I have to connect the DNA actually. I have to connect the DNA, okay. So yeah, because this will not work. Why this will not work? Because I will have to provide the input from here, right, C and D, and I will take the output from these terminals. So these terminals, it is fine. So this terminal output will be what? This will be 1000 volts, that is fine, additive polarity. But here the terminal voltage is 600 volts. But my transformer is not 600 to 1000, it is 400 to 1000. So this will not work, okay. So I have to connect A and D. So now if I try and connect A and D, so that's how you go by with the hit and trial method, okay. You check which one works, which one does not work, okay. So here basically my A and D will be connected. So A will be here. So basically this will be A, okay, no, sorry, this will be A, this will be B, and this will be D, this will be C, okay. And this is the dot and this is the dot. So this polarity is plus minus, where I will give the input, that is 400 volts, and from here I will take the output, that is 1000 volts, right, because this thing is how much? 600 volts, okay. Got it? So I can easily solve this question. So 1600 by 400. So now it is super easy, right? Super easy. So what is the answer? Answer will be, I have to connect the A and D. I cannot connect the B and C. I cannot connect the B and C. B and C is anyways not present in the option, but if it was present, that would have not worked actually. Connecting A and D will work. Common point will be B. Okay, if you see, the common point is B between the input and the output. Okay, between the input and the output, this is the common point. So that is what we mean by common point. Okay, so this will be the answer for this particular question. Connect A and D. Let's now solve this same question only. So in that auto transformer obtained from question 57, previous question, the current in each coil. So current in each coil, what will be the current in each coil? So current in this coil will be how much? So we know the kV rating, right? We know the kV rating, or okay, maximum is 25, rated is 25. So rated current is 25. So if rated current is 25, will it be the maximum current of coil 2 or coil 1? Which one will I choose? So like there is a thing, right? I know the ratio. If for a simple two winding transformer, what is the ratio for a simple two winding transformer? It is I1 divided by I2 equals to N2 divided by N1. N2 is 6000 divided by 4000. So it is 3 by 2. Okay. So if I choose my I1 to be the like maximum current, that is 25, then I2 will it come out to be what? I2 will be equals to 3 by 2, that is I2 will be 2 by 3 of 25, so it will be somewhat 50 by 3, somewhat less than 25. Now if you tell me that you are choosing I2 to be the maximum current, that is I1 is unknown to me, 25 into equals to 3 by 2. Now there will be a problem. So I1 will come out to be, the rated current of I1 will come out to be 75 by 2, that is 37.5, which is not allowed. Not allowed, right? Not allowed. Maximum allowed current is 25. So the 25 ampere is the limit for the primary winding, because it has the it has the lower voltage, so this will be the higher current. Okay, got it, got it. So that's why I2 maximum will be 50 by 3 amperes. I2 maximum will be 50 by 3 amperes. Now what are they asking? They are asking me to find out the value of the currents, in each coils, correct? If I am not mistaken, value of the currents in each coils. How will I find out the value of the currents in each coil? So basically they are asking, actually kind of this question is kind of wrong, but then it's fine. So basically this, right, this coil will carry how much current? This coil will carry 25 amperes of current, correct, from positive to negative. So this is carrying 25 amperes of current. How much is this is carrying? So this one will carry uh, this 50 by 3, correct, 50 by 3. Okay, so how much will this high voltage will be? 50 by 3 only. Am I doing anything wrong here? That is what I am trying to see. Okay, I1 by 2 is fine. Yeah, rated current is 25. Okay, and 50 by 3, 50 by 3. So this will be 50 by 3 only. So this will be how much actually? This will be 125 by 3. Okay, so actually I guess the question is kind of bit wrong in my opinion, because auto transformer, the current in each coil they are asking. What is the current in each coil? Current in each coil they are asking. Okay, okay, am I made any mistake here? So the kV rating, do we know? We don't know the kV rating. Okay, we don't know the kV rating. Okay, they have asked, it is connected to a 10 kVA load. Okay, it is connected to a 10 kV load. If it is connected to a 10 kV load is side is the 1000 volt, right? Because so supply side is 400 volt, load side is 1000 volt. So this is the load side actually. Actually we are not using the rated condition. So if it is connected to a 10 kVA load, I was wrong here. So if it is connected to a 10 kVA load, that means what is the current here? Voltage like the kV rating upon the voltage, right? So 10 kVA 10 into 10 cube upon the this voltage, that is 1000. So this will come out to be 10 amperes. So the load current is actually 10 amperes. This is the load current. Okay, now this current is 10 amperes. Okay, this current is 10 amperes. What about the, so this current is also 10 amperes. So the kV rating will be conserved, right? So here also it will act as a 1000 kVA transformer only. So what is the current through here? So it will be what, 1000 kVA divided by 400. Okay, so this will come out to be 25 ampere. So current through here will be 25 ampere through this coil. Here current will be 25 ampere and current through here will be 10 amperes actually. But they are asking specifically what are the currents to the coil 1 and coil 2. So this is the coil 2 current. Okay, so they are actually, their framing of the question is correct. So gate examiner is always correct. So coil 2 current is, so how much? It is the same as the output current, that is 10 ampere. What is the coil 1 current? Coil 1 current is basically the, what, it is not actually 25 amperes, because 25 amperes is coming from the supply. Coil 1 is different, right? Because from here 10 amperes is going out, from here 25 amperes is coming in. So how much is going out here? 15 amperes. So actually we are not using the transformer in rated condition, that's why I was making a mistake. So 15 amperes. So current through coil 1 is 15 amperes. Okay, current through coil 2 is 10 amperes, current through coil 1 is 15 amperes. So now I can answer, coil 1 current is 15 amperes, coil 2 current is 10 amperes. So option D will be the correct answer for this question. Okay, so yeah, this was actually a good question. Last question was actually a good question, because we are connecting it to a 10 kVA load. So we have to keep in mind all the information. Just be careful, we have to keep in mind about whatever information is given to us. Okay, so let's now solve this next question. So here we have a single phase 50 kVA transformer, two winding, has an efficiency of this at full load, unity power factor. It is reconfigured as if a 500 volt 750 volt auto transformer. Its efficiency at its new rated load at unity power factor will be. Okay, so what will be the efficiency at its new rated load? How do I find it out? We know what is the efficiency formula of a two winding transformer, normal any transformer efficiency formula. Okay, it is X loading into SR into cos phi divided by SR cos phi, the input power, plus the losses. How much is the losses? Iron loss plus the copper loss. Copper loss is how much? X square into PCU FL. So this is the copper loss. Okay, so basically I know efficiency of a two winding transformer. Efficiency of a two winding transformer is given to me, that is 95%. So it will be 0.95. Okay, now it is at full load and unity power factor. So this will be equals to full load, right? Full load means X is 1, so SR is 50 kV only, so it will be 50, like I am writing in kV only, divided by cos phi is also 1, unity power factor. So this will be divided by 50 plus the iron loss. Iron loss I don't know what is the iron loss. Okay, has an efficiency of this at full load. Okay, I don't know what is the iron loss. So iron loss I don't know, Pi plus full load, that is PCUFL. So I know what is Pi plus PCUFL, right? X is 1. Okay, so this value, overall losses will be equals to N to any transformer. Overall losses will be equals to here this value, right? If I calculate it here, this value will come out to be 50. Just hold on. So just hold on. This will be 50 divided by 0.95 minus 50. So overall losses is 2.6631. Sorry, not efficiency, overall losses 2.631 kilowatt. Okay, so this is my overall losses. Now what are they asking? They are asking me to find its efficiency at its new rated load at unity power factor. Rated load means x is 1. So of course, if I want to find the efficiency, right, if I am at its new rated load, so that means x will be again 1 there. Efficiency formula will not change. What will be the efficiency formula? Efficiency formula will be equals to this x SR cos phi divided by x SR cos phi plus the iron loss. Iron loss will not change actually for this transformer. It will have same iron loss, right? Same magnetizing current. Flux is same. Plus x square into PCUFL. Okay. Now as the actually in the previous lecture I told you, like intuitively I told you that resistance will increase, so resistance will decrease. That's why the copper loss will decrease. So losses will decrease basically. Other way also you can understand, as the kV rating is increasing, so the efficiency will improve. Like that also you can understand. So I know that x is 1. If x is 1, this value will come out to be SR dash. SR actually dash. Why SR dash? I will explain. SR dash cos phi is also 1, right? Unity power factor. So cos phi is also 1. Okay. SR dash this will be SR dash plus the copper plus Pi plus PCUFL, that is given here, right? Pi plus PCUFL is 2.631 kilowatt. So 2.631 kilowatt. What is SR dash? SR dash will be the new transformer rating. If I see, they are connected in additive polarity. So these two voltages are added here and the LV winding is there, 500 volts. So NLV, they are connected in additive polarity, so I can use the formula. So this is NLV upon NHV, that is equals to 5 by so this will be 50, so this will be 10 divided by 15 or 2 divided by 3. Okay, 2 divided by 3. So my S dash will be what? It will be the old rating divided by 1 minus NLV divided by NHV. Why can I use the formula? Because I have already checked here that they are actually using the transformer in additive polarity. If they were not, then I would have had to draw the circuit. This will be equals to SR is what? SR is 50 kVA. So 50 kVA divided by 1 minus NLV upon NHV. So NLV 1 minus NLV upon NHV. So NLV is what? NLV is 2 divided by 3. So this value will be SR dash will be 1 by 3. So this is 150 kVA. So as the kVA increases, so with respect to the kVA, the losses are actually very low. So that's why the efficiency increases. So you can understand like that also as well. You can understand it like that as well. Previous lecture I intuitively tried to explain, and here also you can try understanding that same. Okay. So this will be equals to 150 upon 150 plus 2.631. So this value, if I calculate, plus 150 into 150 into 100, of course, right? Into 100, of course, to calculate the percentage. Correct. So this comes out to be 98.27 percentage. If I see that previously it was given us 95%, so it has increased, right? And 98.276. So option C will be the correct answer. 276 also will be there. Okay. So I hope you have understood this question. Like better formula based it is, I do agree, but not that difficult to remember the formulas. Basics we have solved with basics only. Okay. Now let's solve the next question. So this is the next question. So here a 1500 volt single phase 3 winding transformer is being used as an auto transformer. Okay, it is being used as an auto transformer with a supply of 3000 volt. So input side is 3000 volts. Okay. So actually these two coils will be added basically. So I have 3 coils. Okay. I will draw this first. Then I have this coil. Now I have another coil, third coil, that is this 500 volts, right? So I have this third coil, 500 volts here, that is, let's say here only. Okay, so the input side, supply side is 3000, so these two coils will be additive in nature. So here one of the coils will be 2000 volts, other coil will be uh, that 1000 volts. So let's assume, we can assume our design for now, later on we can change it. So this will be plus minus 2000 volts, this will be plus minus 1000 volts. Okay, so plus minus 2000 volts. So now what I can say, transformer is, now the transformer is supplying load 1 at 3500 volts. So the load 1 is connected here, right? This is 500 volts. So this is dot, this is dot, this is dot, this is dot, and this is dot. So this is also 500 volts. Okay, so overall a load is connected in this 3500. So all these are added basically. So this load is connected. What is the value of the load? So the value of the load, if you see, it is like it is 1050 kVA. So this load is basically, I hope you can see, 1050 kVA. Okay, my drawing is okay. Let me bring it to the middle only, otherwise you will be confused. Okay, and next load is connected to 1000 volts. So 1000 volt is actually here only. So this is the other load that is connected, that is here, whose kVA is 180. Power factor they have not mentioned. Okay, the input current drawn by the auto transformer. What will be the input current drawn by the auto transformer? So what will be the current by this drawn by this load? The current drawn by this load will be, it is 1000 upon 180 upon 1000. So it is 180 amperes. That is the current drawn by this load, right? What is the current drawn by this load? 1050 kVA. It will be 1050 kVA upon 3000. So it will be 1050 upon 3. So this value will be what? This value will be 35, right? 350 basically. 350. So 350 amperes will be coming out from here. Okay. Now, or am I wrong? Okay, sorry. This is not, sorry, this is 3500, right? Sorry. So this will be 3.5 actually. So if 3.5 is here, this will come out to be 300 amperes. So 300 amperes is coming here, 180 amperes is coming here. So from here 300 amperes will flow. Okay. From here 300 amperes will flow. From here 300 amperes are coming. From here as well 180 amperes is coming. So overall from here 480 amperes will come. Okay. So from here 480 amperes is coming. Okay, fine. What about the other, like they are asking what will be the supply current? Okay, so how do I find out the supply current? Do I know any other information? Okay. How do I find out the supply current? That is what I'm trying to think. Okay, so I know one thing, that whatever is the output kVA, that should be same as the input kVA, correct? So what is the load connected? Load kVA, total load kVA. So total load kVA is equals to 1050 kVA plus 180 kVA. Okay, so this value will be 50, that is 1130 plus 100, that is 1230 kV. Okay, 1230 kV. Okay, this is the output kV. Who is supplying this? Of course the input. So I have a input source connected here. What is the voltage value? 3000 volts, correct? So I should equate this to the input, because like assumption is this is ideal auto transformer, so there are no losses here. Okay, so input will supply this value, that is 3000 into is. So here is will be equals to 1223 divided by 3, so this will be 410 amperes. Okay, so is current will be 410. Okay, this is the is current. Here this current will be 410. So supply current we have already found out, 410. Okay, what about the current flowing through the 2000 volt ampere, 2000 volt winding? So from here 300 amperes is going out, from here 410 amperes is coming in. So how much is the remaining current? KCL, simple KCL, right? So from here 110 amperes will go out. Okay, so 110 amperes is coming from here, 180 amperes is going from here. So from here how much current should come out? 70 amperes in this direction, 70 amperes in this direction. Okay, got it? Okay, so this is the 70 amperes, this is 110 amperes. So what is the current through the coil? 2000 current will be 110. So this is the first answer. Okay, first answer. Second answer is current through this coil. What is the current through this coil? Current through this coil 2000 volts, 2000 volts is 110 amperes. Okay, what about the current through the coil 1000 volts winding? So current through the coil 1000 volt winding is 70 amperes, which we have already calculated, right? So third answer to the third question, coil 1000 volt is 70 amperes. Okay, so this is the answer. Basically we got our answer. Okay, so now let's solve this. Like this is a very elegant question, because you had to solve with very, like, no formula. Have we used any formula? No formula, but still this question is very good, and this kind of question I'm pretty sure will come in GATE examination. Okay, let's solve the last question of today's lecture basically. So in this question we have been given the number of terms NAD, NBD and NCD. Okay, NAB, NAD, NBC, NCD. Okay, so okay, find I. We have to find out current I. How will I find out the current I? So this is 400 volts. So NAD is 400, right? So NAD will be equals to 400 volt per amp turns is same. So here if I write this upon NCD, this should be what? The voltage across the CD. So NAD is 100, NCD is 50. So I know this is 400, so I can easily find out the voltage across CD. Okay, so VCD will be equals to 200 volts. So VCD value will be 200 volts. Okay, VCD is 200 volts. What about VBD? What about VBD? So NBD, sorry, NAD upon NBD will be equals to what? It will be equals to like 400 volts again is the input, divided by NBD. NBD BD number of turns have they given? 75. Yes, so it is 75. Sorry, sorry. This will be the value that I need to find out VBD. So here the number of turns in AD is 100, correct? Yeah, 100 upon 75 will be equals to 400 upon VBD. So my VBD will be equals to uh, 4 4 into 75, that is 300 volts. So VBD is equals to 300 volts. Now I have to find out this current I. How will I find out this current I? What you can do is you can find out the, like, you can equate the KVA ratings, right? So I know I can equate the KVA. The KVA should be KVA of the input and the KVA of the output should always be same, right? So basically what I can write is this V ED. So basically S in should be equals to S out, correct? So S in is what? The supply is providing the current, right? So V ED into I conjugate. This is what I need to find out, should be equals to my this value V BD into I conjugate. What is the I value here? Can I find out the I value? I know what is VD. VBD is, I had already found out, that is 300 volts. So here it is 300 volts. So what is the current IBD? IBD will be 300 divided by 30. So I just wanted to calculate the magnitude, or angle also you can write, sorry, angle, we have to include the angle. If you don't include the angle, you will mess up. If you don't include the angle, you will mess up, trust me. Okay, so this is a very good question because here the load is complex. So here IBD will be what? IBD will be VBD, as there is no phase difference between VBD and VAD. Okay, so this value will be what? VBD is 300 divided by the impedance, that is 30 angle minus 30. Okay, so this value will be 10 angle plus 30 degree. Okay, what about the current ICD? Okay, ICD current is how much? ICD is VCD upon this impedance. So VCD is 200 volts, impedance is 10. So to be again ICD, I will find out, it will be 20 angle minus 30 degree. Okay, so this will be my ICD, this will be my IBD. So here, right, in this equation what I will write, this will be VBD. Remember, I will not write here I, right? It will be IBD conjugate. Okay, conjugate. That is what my apparent power is. We have learned this very well in complex power chapter, correct? So IBD conjugate plus VCD into ICD conjugate. Okay, so from here I can directly write down the expression for I. What will be the expression for I conjugate? I conjugate expression, what is VBD? VBD is like all this, like assumption is my supply is 400 angle 0 degree difference. So all the other voltages also will be angle 0 only, because there will not be any phase difference, because they are just a constant multiple of turns ratio. So the voltage will not have any phase difference, but current will have phase difference because impedance has phase difference. Got it? So this will be VBD. What is VBD? VBD is this value. Okay, VBD is this value. What is this value? This value is 300 volts. 300 into IBD conjugate. We will actually not conjugate this, we will keep it as it is for now. So what I want to say is, what is my I conjugate? I conjugate is this whole value divided by VAD, right? What if I conjugate this again? I want, like, ultimately they have asked me to find out the value of I, right? Like magnitude will also work, but let's say if in the options they have the phase angle as well, you will be wrong, right, if I don't correctly find out. So I have to conjugate this whole equation. So I conjugate of conjugate will be I only. Here it will be VBD, like if I have two numbers, right, Z1 plus Z2, complex numbers, if I take the conjugate, it will be Z1 conjugate plus Z2 conjugate. This we have studied in class 11. Okay, so this will be what? This is multiplied here. If I take the conjugate, this will be VBD conjugate into I conjugate, IBD conjugate, so it will be IBD only. Okay, plus VCD conjugate into ICD conjugate, so it will be ICD only. Why? Because if I have two numbers Z1 Z2 and if I am taking the conjugate, so it will be the conjugate of individual numbers. Can I prove it? Yes, you can. So let's assume that z1 is magnitude of z1 angle theta 1 and z2 is magnitude of z2 angle theta 2. Okay, now if I multiply these two numbers, z1 z2, okay, this will be what? Magnitude of z1 magnitude of z2 angle theta 1 theta 2. So this will be basically now if I want to calculate the overall conjugate z1 z2 conjugate, so z1 z2 conjugate will be what? Just the angle will be negative, so this will be z1 into z2 minus of theta 1 minus of theta 2. Okay, so like same thing, right? If you had have individually conjugated then added the angle, it would have been same. So same thing I am doing here, so that's why I have proven it to you. So this was just the rough work, right? This was just a rough work. Okay, this was just a rough work. So this will be divided by VAD. Okay, now VBD conjugate will be VBD only because angle is 0. VBD angle is 0. So this will be VBD is how much? I guess 300 volts, and IBD we have already calculated, that is 10 angle 30. So this will be 10 angle 30 plus VCD will be I guess 200 volts. Yes, 200 volts. And then like because it is angle 0, right, it does not matter. Okay, so if I take the conjugate of angle 0, it does not matter. So this current will be what? ICD current. ICD current will be 10 angle 30. Okay, 10 angle 30 am I correct? 10 angle 30 or minus 30? It is minus 30. Okay, it is 10 angle minus 30. 10 angle, sorry, 20 angle minus 30. 20 angle minus 30. 20 angle minus 30. So this will be VAD. VAD is the 400 volts. Correct? So this will be 2.5, that is 7.5 30 degree plus 210 angle minus 30. Okay, so 1 by 210, this is my I. So my value will be, if I want to calculate this value, so 7.5 cos of 30 into cos of 30 will yield me 6.49 6.49952 and plus j 7.5 into sine of 30 will yield me 3.75 and plus 30 into cos into 10, so this will be 8.66 something minus sine 30, right? This will be like minus of this, so 30 minus sine into 10 will be 5 only, so minus of j5. Okay, so from here you can directly find out the value of I. What will be the value of I? So this minus plus 3.75, it will be minus of j 1.25 and this will be 6.4952 plus 8.66, so 15.155. Okay, amperes. Now this I can write in like exponential format. So this will be whole squared plus 1.25 whole square whole under root. So my I current will be 15.2 angle 1.25 divided by 15.155 negative tan inverse. So minus, like it's almost real value only, I mean in phase only, 7.15. okay, because here I had plus 30 and minus 30, right? That's why. So yeah, this will be the answer. So these kind of question also can come in AC, right? This kind of question, you have this AC analysis and this auto transform analysis. So it's a mixed kind of question. So we took almost all variety of questions. We took get PYQs as well. We took few assignment problems which were our own. Okay. So auto transformers is completely comprehensively covered. In the next lecture, we will start a new topic, that is parallel operation of transformers. I hope you have enjoyed this lecture. If you did, make sure to hit the like button. Make sure to comment down below your feelings regarding all whatever concepts you have learned till now, and I will see you in the next lecture. Until then, happy learning.